Okay, so here we are on example 4. And so same idea, except for now, notice where the variable is. It's not the length of one of the sides, it's the angle. But no matter, because we now have this fabulous new relationship between angles and sides. So we still have that tangent of the angle A is equal to opposite over adjacent. So we have tangent, this time A is X, our angle. And then let's see, across from X, this is the opposite side. Next to X, this is the adjacent side. So 1 over 4. Okay, so 1 divided by 4 is 0.25. So what we're going to have to do this time is use the table backwards, because last time we were looking up the degrees, this time we're looking up the opposite to adjacent ratio. So we're looking for 0.25. It's not exactly 0.25, but here's 0.2493. There's also 0.2679, but that's farther away from 0.25. So the closest thing to 0.25, it looks like, is 14 degrees. So our angle is 14 degrees approximately. Okay, so notice in part B, I have a new variable that maybe you haven't seen before. This is the Greek letter theta. It's Greek letter T. So as you get into higher level mathematics, we use Greek letters to represent variables as a variable. Specifically, we use theta. It's like a circle with the swoopy through it, a lot for angles specifically. Okay, so you're still setting this up as tangent of angle A. It's just now going to be tangent theta equals, let's see, opposite is 5, adjacent is the 4, so 5 over 4. So 5 divided by 4 is 1.25. So then we go up to the table, 1.2349, I think is going to be the closest thing, because 1.2799, that's almost 1.28. So what was that, 51 degrees? So theta, our angle, would be approximately 51 degrees. Okay. All right, now we're ready to go to the top of the next page. We're already doing a video lesson. You don't need that. So the idea is these tables, up until about 30 years ago, is how we did trigonometry. But now we have calculators that have the entire table memorized. So you're not going to need the table from now on, because now we have technology. I just wanted to kind of show you the progression of how this all came to be. But your calculator actually has the table memorized. So we're still setting this up the same. This is still opposite across from 60 and adjacent next to 60. So you're still saying tan 60 degrees equals opposite, which is x, over adjacent, which is 5. And it's just that now you're going to go to your calculator. So here's our calculator. And we need to take a step first. So there's actually 2 ways to measure angles. You can measure them in degrees, or you can measure them in radians. So we're going to go to this red mode button here, and you need to be in degree mode. So what you're going to do is you're going to arrow down and arrow to the right till you're on top of the word degree and hit enter. And when you do that, it should highlight the word degree in black. And now you're in degree mode. If you do it in radian mode, it will give you the wrong answer, since we're not measuring our angles in radians. Okay, so then you want to quit. You want to go back to your home screen. So you're going to press second and mode to quit and go to your home screen. And now, do you see the tangent button here is a couple buttons above 9. So tangent 60. And I should have closed my parentheses, is 1.732. So I'm lazy. I'm just going to write that this is 1.732 ... because I know there's more decimals, but I'm too lazy to write them all. Okay, then we're going to put this over 1, and we're going to cross multiply, just like we have been doing in order to get x by itself. So x times 1 is x. 5 times the 1.732 number. So we're going to go back to our calculator. And the easiest way to do this is just press times, and that tells your calculator automatically take my previous answer, that 1.732 number, and multiply it by 5. Enter, and I get 8.66. So I think we're going to the nearest tenth, aren't we? Oh, it didn't say. We'll go to the nearest tenth. So 8.7. Okay, so same idea over here. Let's see, this is opposite across from x. This is adjacent next to x. So tangent of x equals opposite, which is 17, over adjacent, which is 7. Okay, except for this time, this is where my angle is the variable, and this is the one where I would look it up in the table backwards. So what we do for this, what we call this, is we call this tan inverse, to tell your calculator to look this up in the table backwards. So you're going to, you see tan with a little -1 up there on your calculator? So you're going to press second and tan, and you don't have to calculate it first. You can just go ahead and 17 divided by 7, enter, and it's approximately 67.6 degrees. So x, the way you notate that, not that you have to do that for this class, you will do it in pre-calculus, but for now, that's the way you notate that. And then we said, I've already forgotten, 67.6 degrees. So take a minute, and I just want to reflect on, when do you use tangent and when do you use tangent inverse? When do you press which button? So over here, this was a scenario in which we press tangent. So we're going to say use tan, and this one is a use tan inverse. So notice where x is in each of those situations. So we're going to use tan when x is a side length of your triangle. And we're going to use tan inverse when your variable, when x is an angle, right? This is very important to know the difference of when to use tan and when to use tan inverse. Okay, so we'll end this video, and I'll pick up with you on the next video.